Okay, folks, we're still looking at rates, graphs, and slope here, and still talking about proportional reasoning. This is our 92nd installment, still in Section 8.1, which is your 9th unit. So we're going to talk about same stuff as last time, but now we're going to do some practice questions. First one says, a graph is drawn to compare the fuel economy, or fuel consumption, for 4 different cars. Which car is more fuel efficient? So let's look at what we've got on this graph. We've got fuel used against distance driven. So you might think, well, how can I tell which one is more fuel efficient if they don't all travel the same distance? You can see here on this graph that each of these lines reaches sort of different distances over to the right for its distance driven. But it's not about how far you go. As long as you got an accurate sample for the distance that you did travel, then we're just looking at the slope of each line to determine the rate of consumption, or the unit rate actually. And if we're looking for the one that's most fuel efficient, that'll be the one that's got the lowest rate of consumption of fuel. So if we want the one with the lowest rate of consumption of fuel, then we're going after, obviously, the one with the least slope. So car D looks to me like it's the magic winner here. Okay, so be careful. Sometimes you want the biggest slope, sometimes you want the smallest. Depends on the question. All right, so for this one, it says that we're dealing with temperature in the Arizona desert. It rises quickly after sunrise. That makes sense. It gets hot quick in the desert. Sketch a graph of the temperature versus time for the data shown, and use your graph to find the average unit rate at which the temperature is increasing for the first hour after sunrise. Oh, that's interesting. Okay, so the first one, it says right at sunrise it was 14 degrees outside. Sounds cool for Arizona, but not in the evenings, not in the nighttime. So we got, I'm going to guess at that point, looks like it's got coordinates of 0 and 14. So what we're looking at here is we've got temperature on this axis, and that's going to be in degrees Celsius. And then over here we got time, which is in minutes. Okay. The next point says we've got 20 minutes later, we're at 15 degrees. So that's about right here. And then another 20 minutes later, we're at 18 degrees. So we're going to estimate somewhere in that range. And then a full 60 minutes after the sun came up, we're at 22 degrees. So 22 degrees would be up about here somewhere. And then 80 minutes after, we're at 24 degrees. So that's somewhere in this range, just below 25. And then 100 minutes after sunrise, it's 27 degrees outside. Okay, so that'd be a point somewhere in this vicinity. So we could draw this. It's probably some kind of a curve that would go through these points. We can see, whoops, messed up a little bit there. We can see it's not going to be a perfect straight line, but real world data seldom ever is. So what we have to do now is we have to use our graph that we came up with to determine, how do they put it? They want the average unit rate at which the temperature increases for the first hour. So the first hour is going to be from 0 minutes up to 60 minutes. Okay, so we're going to take these 2 points and we're going to find the slope of the line to get our average unit rate over that time. Okay, makes sense. So our average unit rate is going to be the slope, and that will be equal to the height at this one. So at 60, that height was 22. So I want 22 here. Subtract what our height was at 0, which was 14. And that's got to be divided by 60 minutes minus 0 minutes. So you end up with 8 divided by 60. All right. So I guess what we're looking here, yeah, this is going to be an average rate. So we get 8 divided by 60 is about 0.133. So I'm going to say it's about 0.133. And this is going to be in degrees Celsius per minute. So that means that in the desert, after the sun comes up, the temperature increases at about 0.133 degrees Celsius every minute. That doesn't sound like a big number, but when you consider that, what that really means, 0.133 degrees per minute is more than almost 1.5 degrees every 10 minutes. It's a very quick rate of increase of the temperature. A graph can be used to get a visual interpretation of how one quantity changes with respect to or compared to another, and the slope gives us our unit rate, as we saw. Steeper graph, higher rate, less steep, lesser rate. You got it. Good luck. See you next time.